I'm going to introduce our next speaker. His name is Lars, and he's the CTO and VP of engineering at Cenzic. So go ahead.
Thank you. All right, can you guys hear me all right? There you go. Couple of things up front. So this session is it's going to be more about basics, right? So if you are very familiar with session management and HTTP low-level stuff, then this might or might not be the right session for you. But I do have some jokes in there. So there's various little cartoons in there to keep everyone engaged, even those of you who might think, why is he telling me what I already know? For those of you who don't know so much about it, you get the jokes and you get the content. So we'll see. I'll ask you later whether you like the jokes better or the content, or maybe I shouldn't ask. All right, agenda, and there's the first joke. I'm not going to read the jokes unless you tell me you can't read them back there, then I'm going to read them out for you. So I wanted to talk about, as the title suggests, session management, right? Explain a little bit what the session is, why do we need a session. That's very basic, so I'm not going to spend a whole lot of time on that. Then talk about the security implications thereof, some of the techniques that you might or might not have heard about, how people go about actually attacking sessions-related vulnerabilities, and then some best practices at the end. Pretty straightforward, okay? And one thing you will notice is that the jokes that come free with the presentation, have a lot to do with little password jokes. So you could argue, why password jokes in a session management? Well, it's because it's related, and we'll talk about that as well. All right, another joke. How about that? That one I like a little better. If you do have children, you might appreciate this one as well. But so why session management? This is OWASP, and so, most of you will know this, but there's always the off chance that one or the other in the room isn't quite so aware of it. HTTP in it by itself is about as stateless as anything can be, okay? There's no state, there's no concept of a session per se built into the thing. So ultimately, every request is a unique request, and that presents you with a dilemma. HTTP works just fine in its original intent for statically linking content, right? But if you're trying to have application behavior and you're trying to have stateful sessions, that doesn't work. So how do you do that? How do you go about creating sessions? And we'll talk about that. And a lot of that fundamentals, even though half of you, I'd say 95% of you probably know, and that's why the joke is there, so you don't fall asleep on me. I have to make sure we all get it, because otherwise you're going to be lost in the rest of the session, okay? All right, so with that being said, a few data points. Cenzic, for those of you who don't know about us, we are one of the leading vendors in the web application vulnerability assessment space. We have on-premise, and I'm not going to do sales pitch, so bear with me. We have on-premise, but we have SaaS. And the reason why I'm even saying that, because with our SaaS practice, we have very valuable data we're collecting, right? Anonymized data, so but we know based on our thousands of assessments that we're doing every year, that what we find, what we don't find. So if you relate that, and by the way, as a result of that, we publish a trend report, I think every half year, that talks about the data we see both in our own practice, and we also harvest various well-known databases for data as well. As a result of that, we published this trends report, and the thing I wanted to point out for commercial applications, off-the-shelf applications, so the SAPs, the Oracles, the various other things you can buy off the shelf, we did some analysis like we do every half year, and you will see that I've circled two numbers here where I feel that they're somewhat related. One is CSRF. Anyone heard of cross-site request forgery? Most people probably have, right? I took the liberty and said that to me is somewhat session related, and we'll talk a little bit later about. And you can see that's 6%, so that's meaningful overall, right? And then I circled the other because unfortunately it's in the other bucket. And when you go into the other bucket, you will see that there's 64% of the other bucket, which the other bucket was 16% of the overall to begin with, so pretty high. That talks about permission, privileges, and access control. And again, I took the liberty of interpreting it that way because somewhat that's all session related, okay? Ultimately, these all go hand in hand. So those are good data points. I've got even stronger data points for you. Proprietary applications, as per our trend report, okay, that's our terminology. Proprietary means we have been testing these. So these are the thousands of assessments we keep doing for customers' applications, self-built, homegrown applications, which really is quite different. And you can see here that we find about 80% of them, and this is slightly different to read. The way you read this is out of 100 applications, if you will, 80 of them are vulnerable to authorization and authentication flaws. That's a really high number, right, when you think about it. And 68% of them have session management issues. And as we go through this presentation, you will learn more about what we mean by session management challenges. And 20%, and we see that number growing, by the way, are susceptible to cross-site request forgery, which we're going to talk a little bit about as well. So session management, I wanted to show you the quick trend. We've seen a little bit of a down here in the last trend report over the other one, but it's pretty stable overall. In all, it's a pretty high number, and it's certainly not that we solved that problem. Okay, what do we mean by that? By session management, it's a big bucket of various vulnerabilities that we consider under that umbrella. Weak session randomness, ineffective session termination. We'll learn a little bit more about that, session fixation, stuff like that. Authorization, authentication flaws. You can see that keeps growing and growing. Interestingly enough. I will caveat this with one statement, which is also keep in mind that our technology, our way of assessing as an industry is getting better too, right? So I wouldn't necessarily right away read into this that applications are getting worse, because it might well be that we're just getting better in finding vulnerabilities, but the numbers are still nevertheless pretty alarming, to say the least. And what falls into that is brute force logins, unauthorized resource access, privilege escalations, all these kind of attack vectors we umbrella under these 80%, okay? And then cross-site request forgery, I'll have a small section here in the presentation where I'll explain that in layman's terms, so if you are not familiar with that, bear with me. If you are, I put yet another joke in there, so you're going to stick around when we go to that section. And that is that's growing. We've got that at 20%, this last report. Joke. I like this one. Can you guys actually read those in the back, or? Again, just trying to keep it entertaining, guys. It's funny. I will share one quick experience before I keep going here. I didn't realize the power of Google. I mean, we all kind of, are using it for various things. But if you're ever looking for jokes or anything like that, it's amazing how you go to the image search and it's spot on. I mean, I did not have to spend a whole lot of time finding a few good jokes for the presentation. Let's put it this way. So kudos to the Google guys. All right, so let's go in. Let's go a little deeper here. So session management. First question you want to ask yourself in this context is, how is it implemented? Remember, I said it's stateless, HTTP by itself. So how do you do it? Again, these are a little bit fundamental things. So for those of you who know, just hang in there, please. So how do you do it, right? There's various ways of how you can do it. One of the early ones that has been used in the very early days was through a concept that's built into the HTTP protocol. It's called HTTP authentication. There's various sub-flavors of that. And basically the concept is very simple, right? The browser, for every request, it will send along your credentials. So the first time, the server will say, I don't know who you are, tell me who you are, I put in my credentials, and then every subsequent request for the session duration, it will send that right along, and then you can have different security flavors. That's been used for a while. It's not necessarily what people do anymore, by the way. The other way is that conceptually, that's still right on, right? You need to find a way of how you connect the state on the server with the client request, which is stateless, remember? So you got to send something along. If it isn't the browser sending the credentials along, then as a minimum it needs to be some token, something that you send along. And with that came the concept of cookies. I'm not going to bother you with cookies. I'm just assuming we all know cookies, and I'm not talking about the one you eat. So the cookies are the next concept that we had, and the principle is the same principle, right? From a browser perspective, again, I'm being very fundamental here, so I hope I'm not boring. The cookies get sent along, right? So the first time you make a request, that server will tell you, here's a cookie, please stick it into your cookie cache, and then as a browser, you will say, every subsequent request that I sent to that same server that sent me that cookie, I'm going to send that cookie along seamlessly. And then there's expiration dates and all kinds of stuff. I'm not going to go that deep right now. But the point being, you just found yourself a way of how you put something with your request that lets you mimic that session management capability in the form of cookies. By far the most often used mechanism these days, okay? There is the other variety where you say you actually put something in the URL. could be URL parameter and its value, which is something like JSession ID. Well, most of you might have heard of that. Very common. We'll talk a lot about the problems with that. But you know what? As you start doing MVC-based applications and you're mapping path, it could be anything. It could be a sub-element in your path that gets mapped on the server side, okay? So don't get hung up only on the parameter value pair there. And then last but not least, the other thing you can do, and one very famous framework that all of you probably heard of, being ASP.NET from Microsoft, is that you actually start doing it in a more, what often is referred to as a sessionless client state model, where you actually take a view state, as they call it, and others have mimicked that since, a view state, and you put it on the client. So all this state that you are trying to classically maintain on the server and connect that to the request, you just pump it all the way down to the client, and the client keeps that state. Therefore, when it makes the next request, it sends the state back, along. Make sense? That's another way of doing it. Two side notes here, a little bit more information for those of you who don't know. In the case of Microsoft's view state mechanism, you've got the enable view state Mac, and I think they've changed the default behavior, so maybe you don't have to worry anymore. But in the early days, you want to enable that, okay, so that at least it's hashed up, and the view state isn't that obviously viewable. And the other thing though to keep in mind is that the hash really only does one good thing for you. It doesn't let you tamper with it anymore. I'm not going to go into encryption basics. You all know that. So it's hashed. You can't mess with it. If you mess with it, the server will know you messed with it. Don't think it's going to give you obfuscation. Okay, it's very easy to take the view state and at least decrypt it to the point that you know what's in there. So it's funny. Some people relied on that in the early days and thought, oh, if I hash it up and I actually have my here's a good hack example, right? And I have my shopping cart, and the price tag for my sneakers that I'm about to buy is in the view state on the client, but I hashed it up. Hashing up is good in this case because I couldn't tamper with that anymore, right? In the past, if you don't hash it up, I could even tamper with the price. So if it's $100, I change it up on the client, I send it back, and I just bought it for $1, and the server doesn't have any state, it's going to accept it in the worst case. If you hash it up, I can't do that. But if there is something secret in there in that state that you don't want anyone to know, hashing is not going to help, okay? I can still figure out what's in there. Make sense? All right. Still somewhat basic here. The other thing is as you start accepting the fact that you're going to have to send these tokens down the wire, because that's how you're going to connect, what is a good token, right? What all goes into tokens? And of course, if you use one of the big frameworks, they often make that decision for you, so you don't have to worry so much about composing your own token in the early days. But even till this day, we see plenty of homegrown in our practice, security practice. That's up to you. It could be anything, right? So it could be a combination of user info, account info, diamond date stamps, random generators, email addresses, IP address, sometimes popular, so that at least it's unique to that client who makes the request. Why is that important to understand? Because obviously when we talk about attack vectors here in a second, you want to, the first thing you do is with any attack, you're trying to figure out what's the token composed of and how can I mock with it, right? So understand that. Then of course you want to probably, and most frameworks will encode that, whether it's XOR or base64. Again, that's not really giving you security out of box, right? People can figure it out and they can decode and they can still try to make sense of it. It's just adding layers to the onion of security, if you will. It's the onion security problem. And then last but not least, people can obviously try to listen into your traffic. We've all know about that one, and HTTPS is going to help. I'm going to talk about that in a second as well, because one of the problems with that is that people have gotten that, okay? So only took us about 10 years to realize that HTTPS is a good thing. We're making fast progress as an industry. What we haven't quite realized yet is that you have to do it consistently. Okay, we've seen plenty of cases where, I'll give you some examples where this is broken. One thing you might do is you might say, hey, cool, you know what, I'm going to give you a token when you first come to my site. It's already there as a cookie. When you authenticate, I'm going to now take that token on the server side and I'm going to attach to that token a state that says that you've now been authenticated and logged in. So far, so good. The problem is the first part of the communication wasn't done over HTTPS. So that very token was in free traffic. And then afterwards, it got associated with state. That's no good, right? Because the first part I might have still snooped out your token, and then all I have to do is wait till you authenticate. Now I can use your token against you. Make sense? That's one problem. Another problem that people don't realize sometimes is they say, cool, I'm going to use HTTPS only for critical content, right? So I'm logging in. It's all through HTTPS. Oh, there's a help button. I'm clicking on the help button, it pops up some generic text that says, here's how this function works. Guess what? The developer thought, I don't need the HTTPS overhead for help. There's nothing sensitive in help. What's the problem? What's the browser do? The browser's going to send that cookie along anyways. Okay, so that isn't going to work. So there's various variations here. I could go on for a little while, but just to give you some flavors, HTTPS is a great thing. Use it consistently, or you're still not